Okay, so let's see how the formula works in the context of a specific example. So we want to find the length of this curve that we've described by this vector valued function from t equals 0 to t equals 1. So just as a reminder, if you actually plug t equals 0 in, here you get the point 1, 0, negative 1. If you plug in 1, you get 2, 2, 3. So we want to find the length of the segment of the curve between those 2 points. And we know how to do that. We know that the length of this segment will be the integral from t equals 0 to t equals 1 of the magnitude of r prime of t dt. So a good first step here is to actually figure out what r prime is and then calculate its magnitude. So this isn't too bad. To find the magnitude of r prime of t, we first find r prime of t, which we get by just differentiating each component here separately. So that's not particularly difficult. To find the magnitude, we'll find the magnitude the same way we always find the magnitude of everything. We square the first component, 1, square the second component, 4, and square the last component, which here will be a 36t. OK. So if we take a second to sort of just clean this up when we write it in the integral, 1 plus 4 is pretty clearly 5. What we have to do is we have to integrate this 5 plus 36 t dt. And so just as a little comment here, this magnitude of r prime of t sort of hides within it a square root. So when you're doing these problems, you have to integrate square roots, which can be downright unpleasant to impossible. But this particular expression isn't too bad. It's just a square root of a linear function in t. And whenever we have that, we can get away with just a u substitution. So one thing that you can do is you can let u be 5 plus 36t. You've done a lot of these before, so I'm going to ask if you're not comfortable with doing the u substitution, or if you want to do the u substitution for practice, pause the video here for a second and go through it. And so if you do it, what you should wind up with is just 1 over 54 times 5 plus 36t, all to the 3 halves. And we have to evaluate that from t is equal to 0 to t is equal to 1. Okay, so once again, make sure that you can do that computation by yourself. But now all I have to do to find this actual length is just plug in t equals 1 and t is equal to 0. So if I plug in t equals 1, I wind up with 54 times 41 to the 3 halves. And if I plug in t is equal to 0, I wind up with 5 to the 3 halves. And so the length of this curve segment, it's not a particularly pretty number, but it's not that bad to calculate. So this is a pretty prototypical example, but it's one where the actual integration isn't too terrible.